The next set of key value pairs is the data event management group. Now, one of the key features that IOblend automatically exhibits with streaming sources is its ability to handle event windows, late arriving data, and then what we call regress, which is what does IOblend do with that late arriving data. So an event window basically describes the duration that we hold the data within our internal table. So if I've got a streaming job which is going on for a number of weeks or continuously for a number of months, every time it reads a source or reads data from its source, that data will be stored and reside in its internal table. So therefore, over a period of months, that table is going to get quite big in terms of the amount of data that it's storing. Now, typically for streaming jobs, you only want to, your transforms are only executing on a subset of all that data that you're reading. So so therefore, you don't really need to store all of that data for the complete duration of the length of the time that the data pipeline is actually running for. So therefore, an event window is generated which defines the amount of data we actually need within our internal tables based upon the processing requirements of our transforms. So we can set an event window by assigning apply events to true. And then likewise, regress events is if we want to handle late arriving data. So in this instance, I want to handle late arriving data, so I'll set that to true. Now, in order to be able to set an event window and to manage it, I need to supply a key from the internal table, which can be used to identify new records based upon a time. So the value here we're going to use is created date. And you also need to supply the time date format, which tells Spark and IOblend how to actually read the date and the time elements of that field of the event key. And this is a standard Spark format of how you specify dates. So you can look up the Spark documentation to get the full list of how to specify this if you don't know. Next is the event window span in seconds. So this describes how much data we actually want to keep within memory, and it's done in seconds. So here we've said actually we only want to keep 3,600, which is 1 hour's worth of data within memory. So anything beyond that, it will be purged and removed. So late data event window epochs. So this is saying, okay, if I have late arriving data, how much data should I be pulling back? So the way IOblend processes late arriving data is it says it will go off to the archive records for that particular source, and it then will retrieve all the historical data which is greater than the event date or the event key of the late arriving data which has been read. So an example would be if I was to read a new record which was late arriving, which had an event date, in this instance, created date of the 17th of this month, so 17th of September. The regress would then go away and go to archive, and it would pull back all data which is greater than the 17th of September up until an endpoint. And that endpoint is defined by the late data underscore event underscore window underscore epochs. So in this instance, I've set it to 1 hour. So what that means is it will go and pull back all the historical data from the 17th. Let's say it was 17th of September at 2 o'clock up until the 17th of September, 3 o'clock. So it adds 1 hour to it. Likewise, I could add a number of days. So that could be 10 days I add onto it. So that defines how much of that data is pulled back. Conversely, I can also set that to 0, and in which case it will pull back all data from the 17th of September until the current date. Once it pulls back all that data, it will then load it into the internal tables and then reprocess all the components for that data pipeline. So if this streaming source is connected to this transform and to this sink, it will then reprocess the transform and the sink for all the new data, all the regress data that it's just reread. Okay, one of the key reasons why we do this is it ensures that where we need to process a series of transformations for later arriving data, we can do so. So a good example would be, let's say we have a supermarket which has a number of stores up and down the country. We're reading real-time data from each one of those stores. Now, let's say that today we're processing that data, and network for one of those stores has gone down, so therefore we're not receiving any real-time data for that store. Now, let's say that tomorrow that store's network is restored and we start receiving data from that store. Now, if we had a transformations or several transformations which are actually calculating, let's say, the total sales across each stores by hour, because the network has gone down, it means that all the data for today would have been incorrect in terms of the aggregate of those totals. So when I receive the data the following day, what will happen is that we want to be able to pull back all the historical data, so yesterday's data, for all of the stores, and then recalculate all of those aggregates to ensure that we now have the correct aggregates of total sales across all stores by hour. So that's a good example of why we want to pull back data and reprocess all of it. In this example, I'm going to set it to 10 days, which is 8, 6, 4, 1, 2, 3, 864,000. In order for your late arriving data to be processed and in order for an event window to happen, what we need to be able to do is to actually archive the data which is being read. So all data which is going into an internal table for a source will be archived off to a particular place which we define here. And when an event window occurs, that data will then be written to the archive place. And when a regress is required, that data will be read and pulled back from that archive place. So for this example, we're going to set it to S3, and the archive location is, okay, so let's put that in. And as previously mentioned in other demos, we can then set the debug options. In this instance, I'm going to leave it as it is. And lastly, we need to set the Spark option. So just need to add, because it is a common separated or a series of common separated files, we need to provide the separator, which separates the columns within that file. In this case, it is a comma. And also, because I know that these files also have a header and that the first record is the header, I need to set header to true. So that's done. Now that's done, we obviously have to now save that data pipeline because I've made changes to it. So let's save that. Okay, ideally what we need to do is we need to set a sink or associate a sink to it. The reason why we need to do that for this example is an event, in terms of apply events and regresses, if they actually occur due to data which has been read, will not be executed until the data is actually written out. And the reason why we enforce this is to ensure that if there is a failure in a data pipeline for whatever reason, let's say there's a hardware failure, and I read source data and it's identified that an event window needs to be changed or a regress event needs to happen, we don't want that to happen until we've actually physically written out the data which is associated to that source. Otherwise, if we did do the regress or the event and we failed to write it out, when we reran that data pipeline, once the hardware comes back up, we'd be reprocessing that data. So to ensure that doesn't happen, we only execute the event process and the regress process after we've physically written out the data associated to that data. From a designing and development point of view, I can create a number of components here, and I can test them without having to run every single one of them. And the way we do this is just simply by switching off the run order. So if I set the run order to, so if I wanted to test just this, streaming source and I don't want to run the existing pipeline, then all I need to do is set the run order for each one of these components to 0, and the IOblend engine will ignore them and will not execute them. So let's do that. Okay. And let's say the data pipeline, because I've now made a change to it. Okay, so for completeness, in order to allow the eventing to work properly, we have to associate a sink to our streaming source. So what I'm going to do is borrow this sink that we already created and connect it to our streaming source rather than the transformation. So first of all, we need to delete the existing dependency of this sink to this transform. And the way we do this is clicking on the dependency, so that's the blue line. As you can see, it now changes to an orange, which indicates it's been highlighted, and go up to the delete button, press delete. It then gives us a notification asking us, are we sure we want to delete it? So let's just click on that. And now that dependency is gone. To create a dependency between this sink and this new streaming source, all we do is we go to the dependency button up here, click on it, and then we click once on the first object we want to link, and then to the second object we want to link, and then it will automatically create the blue line, which shows the dependency order 1 there. And let's create a run order of 2 here. The link again, so from there to there. And then if I look at the dependency, it's now correctly identified that dependency is the source stream S3 sensor. So again, when you're creating dependencies, make sure you've got the run order set correctly, otherwise you will get that. Okay, so now we've done that. Let's save the data pipeline, save. Okay.